Hey, Accelerated Algebra 2. Just want to go over section 5Q with you. If you have a graphing calculator, it'd be good to have that out. I don't have my emulator on this computer, but I'll talk you through doing any of the math that we'll be doing. So we're going to be writing quadratic functions to maximum or minimize the quantities with real world situations, which real world, okay, whatever. It talks about the price in March was modeled by this quadratic formula or equation where x equals 1 is March 1st, x equals 2 is March 2nd, etc. What was the price of gas on March 17th? So that means I'm going to do P at 17, which means I'm going to go 0.23, and then I'm going to plug 17 squared in minus 0.506 times 17 plus 3.14. So if you plug that into your calculator, it's just going to be 0.23 times 17 squared minus 0.506 times 17 plus 3.14. Oops, I made an error. 5.06. There was my error. So the silliness about this says price of gas is 6.008 if I did that, which is ridiculous. Which day were gas prices at a minimum? So if you think about this, this is a parabola that basically would look like this. The reason I know that is because it's because I have my a value is positive, so it opens up. So if you graph this on your graphing calculator and you plot it in 0.23 x squared minus 0.506 x plus 3.14, and I hit zoom zoom fit, which is zoom 0. Zoom is at the very middle top, and you'll notice however your calculator does it, it should show some sort of parabola. So being that we're looking for a minimum, the minimum is where the vertex is taking place, and the x component would be the day, and the y component would be the price of the vertex. Okay, and of course you know that to find the vertex of a parabola, you could do negative b over 2a, plug it back in. Or if you looked on your calculator, once you have your graphing or your quadratic graphed, and we could do this in class as well, so I'll walk through it in class as well. So we're going to go to second trace. Trace is at the very top right above the arrows, which is second calculate, and we want to look to find a minimum value, which is number 3. And you notice it takes you on the cursor. As long as you can see the vertex, if you can't see the vertex, zoom out your calculator a little bit. But you're going to take your cursor to the left side of where the vertex is, and then you're going to move it all the way around to the right side of where you think the vertex is. You're going to hit enter twice. Notice it says guess. Hit enter one more time. And this is going to tell you at 1.10, we're at 2.8617. So just after the first day, March 1st, our gas was $2.86 a gallon. Okay, please know we can do this during class. We can talk about it during class. And then what was the minimum price in March? Well, the minimum price in March, it was $2, 2.86.17. You know, we'll just round that to 2 decimals. So which day in March? It was the first day in March. March 1st gave us the least amount of money. How much was it? It was at $2.86 for that day. And again, let's talk about this in class on the calculator. Okay, this is a classic problem. We are trying to maximize our area, and we have x is equal to the width. So find the expression of L by subtracting the widths XX from the amount of fencing. Divide by 2 if both lengths need fencing. What is the maximum area of the equation? Okay, so if we call this side X, let's see, how am I going to approach this? What is the maximum area of the equation? All right, I am going to change that. This is going to be our length. We'll call that our length. And then these are my X's. Okay, so somehow we have these taking place. Find the length of the expression by subtracting the widths. Okay, so these are all of our widths. We have all these X's. Okay, divide by 2 if both lengths need fencing. Okay, so I'm going to call this 1, 2, 3, 4, and 5. Okay, so notice we have length times width is in order to find the area of our thing, but we had all of these X's broken up. So we happen to have these same exact lengths here, 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 and here. So I have 1, 2, 3, 4, 5. I have 6 of them. So I happen to have 6 X's in length. Okay, so you could go L divided by 6, L divided by 6, because we have 6 equal regions, times 6x, and then of course if you cancel out, it gives you the length times the width. Okay, what is the maximum area of the equation? Okay, what's the maximum area of the equation? Well, I want to talk more on class, because normally we would tell you that we have some perimeter equals some amount, that we have a certain amount of fencing, and then we would have broken it into these regions. But what I could do is I could say that because I have these 6 regions, so what is the maximum of length times width? So if I put this together as an equation, this is going to work a little bit better. I think we're missing a little bit on this problem. So we're actually going to skip the rest of this because I don't think they shared enough information. This one's going to be a little bit nicer for us. So we have 600 feet of fence, okay, and we have a barn wall that's on one side of it. And so the width we're going to call X, and then the length, we have one length here. Okay, so I want you to think about this, that the area or the perimeter of this equation would be X plus X plus X plus L. Okay, we don't have to use the barn wall because we're not going to put a fence along it. We're using that, you know, it's backing up to something that is acting as a wall as it is. Okay, so length would be equal to P minus 3X. Okay, and how I did that is I realized I have 3 X's right there. I subtracted the 3X, brought it over, so that's what our length is equal to. Our area is going to be X, the width, times the length, which is P minus 3X. Okay, what did we know that the perimeter was equal to, though? They told us the perimeter, we have 600 feet of fencing, so I'm going to plug that in here. So then I have this equation, area equals 600 minus 3x. Okay, we want to start answering these questions. So I'm going to go ahead and graph this equation on the calculator. So you're going to go y equals, clear out anything you have in y equals top left of your calculator. So you have x times 600 minus 3x. And then we're going to go to a zoom, very top middle button, once that's plugged in there, and you're going to go to a zoom fit. And that's going to change the window on the calculator. Hopefully we can see the vertex. If you can't see the vertex, meaning where it changes direction, go ahead and hit zoom out and hit enter. And perhaps that might show a little bit more. Mine's still not showing quite there, so I'm going to hit enter one more time. So I'm changing my window. And so now I'm seeing I have some sort of parabola that does this. Okay, but you have to zoom out in order to get that. What I want to do is I want to now find the vertex. Okay, so the vertex is going to be a maximum value because it opens downward. So I'm going to go second trace to calculate. I want to find a maximum. And I have a cursor that shows up. So I want to be on the left side of the cursor, hit enter, and move our cursor over to the right side after it starts coming back down on a parabola. And this is going to show us that we're going to have a vertex, and we're going to round this to 100, comma 30,000. Okay. So if I have a width of 100, so these values here are 100. 100 plus 100 plus 100 is 300. I know I have 600 feet of fencing, so this has to be 300. So then my maximum area, so the width to get my maximum area. So if I have a width of 100, I have a maximum area of 30,000 square units. What dimensions maximize the area? 100 by 300. Okay, so you're going to have an x value of 100 and a length of 300. And what is the maximum area? The maximum area, we already said it. It's going to be 30,000 square units. And I forget what it was. Square feet, actually. Let's make that feet. Okay, again, we can go over these more in class. A dog breeder wants to create a pen with 5 runs for new litters of puppies. They have 900 feet of this fencing. Okay, so this one, we're going to create a rectangle, and we're going to create 5, 2, 3, so 1, 2, 3, 4, 5. We have 5 regions. So if we know this is x, then I know that's x and x and x and x and x. Okay, each of those widths are x. So I have 1, 2, 3, 4, 5, 6. I have 6x because there's 6 of them. Okay, and then we know that our length, if all those are that, and then we have a length of a certain amount, and we have a length on top and bottom. So my perimeter is going to be 6x because I have 6 of these. So 1, 2, 3, 4, 5, 6, and I have 2 L's. And so we can start solving this. So I want to figure out what the length is in terms of x. So I'm going to subtract 6x from both sides. And then I'm going to divide everything by 2. So I know that the length is equal to p over 6x divided by 2. And they told us we have a perimeter, we have a maximum of 900 feet. So I'm going to plug 900 in for p. So p equals 900. So I get 900 minus 6x divided by 2. Being everything's divisible by 2, I can say that it's 450 plus 3x is the length. So I'm going to do area equals length times width. So length we found is 450 plus 3x. And then the width we know is x. So I'm going to go ahead and graph that on my calculator. So go back to y equals. Oops, I went too far. So I'm going to go in parentheses 450 plus 3x. Oops, should be minus 3x. Sorry about that. Should be a minus right there. That should be a minus right there. 450 minus 3x times x. And x is over by the alpha key. It says xt, theta, and n. And then we're going to get zoom 0, which is zoom fit. So as long as we can see the vertex when it graphs, we should be fine. Okay, so what I'm going to do is I'm going to find the vertex. So I'm going to go second trace. I'm going to find the maximum value. I go to the left side of it, and then I'm going to move my cursor over to the right side. Make sure you hit enter each time. So this tells us that when my x value is 75, my maximum area is 16,875. So each run will be, being I know my perimeter is 900, and my x value, so I'm going to go minus 6x. Being my x value is 75. Oops. So I go 900 minus 450. How I got the 450s, I plug 75 in for x. So that tells me my length has to be 450. Okay. So being I have 5 equal sized pens, I'm going to divide that by 5. So each run will be 90 by 75. Okay. And then I would, it doesn't ask, but we would have a maximum area. Once I do that, my maximum area would be 16,875 square feet. Okay. Again, let's bring any questions you might have to class, and we'll talk about it during class. Have a great day, everybody. Take care of one another.